you have
This
any queries?
conference will now be recorded.
So in yesterday's session,
yesterday, no, but just one thing I reviewed, I think the code I saved,
okay.
based on our because I saved all the code we have
Okay.
talked. But for me, I think because I didn't find we talked about the poly, what's the poly things.
Okay, dynamic binding, dynamic polymorphism.
Yeah,
Okay.
I think probably I think probably you discussed with Daniel. Yeah, I think so. I couldn't
Okay.
find yeah.
Okay. Then fine. So
Yeah,
what we do, so we'll continue with this multi-threading. So
yeah,
again
sure.
after that, so by tomorrow class we'll see that. So we
No
are in the
problem,
meanwhile.
Yeah,
We
sure.
have thread priorities. So we'll do with this multi-threading. So after that, after this multi-threading, I'll be telling you tomorrow or after completing this, we'll see that.
Yeah, sure.
So yesterday we discussed about the thread priorities, and there are two ways of creating a thread. One is by extending your thread class, and one more is by implementing your runnable interface.
Yes.
Right. So now we will be seeing. So even I had taught you that thread priorities, and so you have a methods to set a thread to get a thread, right? So and
Yeah. So.
we will, you want to tell something?
Yeah. I think the thread priority, I saw it also from my side, not here when I doing some profiling, the performance thing, like in the JV2 VM, when I take thread down, I can see each thread which have a thread priority. I think that's this, right?
Yes, exactly.
Yeah. When I take a thread down, I can see each thread trace, each thread ID, there will be a thread priority.
Yes.
I think that's the same thing we are talking here, right? It's the same thing.
Yes. So actually, as a Java developer, like when it comes to performance, you see more about this threads actually. So when it comes to the Java developing, what you see, you will be seeing how to create a threads and how you handle these threads and how is yours internally. So when it comes to the performance or you are whatever you are learning, maybe the performance testings or something else. So in that case, you will be learning more about internal things of a thread, like how a thread has been like the performance is going to affect, and what is this things you will be learning somewhat internally, a part of development, right?
Yeah.
So you will be getting the scope of both actually. So understanding of this also, I think it will help you to relate that both, right? So you may have better idea.
It's good. I mean, it's good. I also it's good. I hear it also from you from here. Yeah, like to enhance, to enhance my understanding also. Yeah.
Yes. So you can, what you do, you just do interlinking. So like there is in this universe, there is something with everything is like whatever the subject that we learn, always your Java has obviously linked with your testing, or everything is interlinked, right? So whatever you see, there is something very different. So in testing, you run for the same topic. For example, for the threads, you learn some other topic. When you do performance testing for the same threads, you learn some other thing when you do when we are in for this development, right?
Yeah.
And we will be seeing some different kinds of methods here, like yield, sleep, join. So we'll come with the first of all with the yield. So what is this method is, so for example, assume that you have you can see there are thread 2, thread 3, thread 4. There are many threads that you have from thread 1 to right. So assume that your process is only executing your thread 1. So don't worry about this yite and all this. So I got this is from the internet and I just got it. So don't worry about the sketches actually. This height and these things are there, right? So don't worry. So just concentrate on these things. Okay. So you have a processor. Assume that your processor is executing only the thread one. Assume that your thread 2 and thread 3 and thread 4 also have the same priority. And assume that your processor is not giving the chance. Your processor is not executing the other threads. It means your thread scheduler is not giving the chance for others. But these are very minimal things. And what you want some other thread to be executed. And what you want this thread one, which is executing on the processor, to go to the wait state. So then what I'll do on this thread one, I'll call a yield. So on whatever the thread you are calling a yield method, what happens? That particular thread will go to the waiting state. And it is totally depend upon the processor, how much time it is going to wait. And whenever a thread goes to the waiting state, obviously your processor will take some other thread. So that's what you are giving the zero idle time for the processor. It means you are not giving the processor in a rest, right? So obviously your processor will start executing something. So you don't guarantee what is a thread. It may execute thread 2, thread 3, thread 4, or anything, because it is all it is totally depend on the thread scheduler and a processor. You don't guarantee which thread is executing, right? But what is the scenario here? When I want that particular thread to go to the waiting state, I can call an yield method. You can call wait method or different things, and we'll see. So you see, this is a life cycle. Or
Yes.
want to ask something?
Yeah. Can you please go back to that slide? I just want to read what here the message static oscillator class and it can. Okay, I see. Yes. Okay, I see. Yeah. I think I got to the point. If you want to put some thread in waiting and you want to to give the way to some more priority thread, and you use this one, right?
Yes.
It's like the thread one say, okay, I will wait. Thread two, you are more important. You are in a high priority, and then you should come to the process. Something like that.
Whatever you said is correct, but not in this case you are not giving to thread two. We'll discuss one method. Why I'm telling, because in yield we don't guarantee which thread to be executed, right?
Oh,
For
sorry.
example,
Yes. Don't
when
correct.
you
Yes.
so when you made, for example, you want thread one to go to the waiting state. So I will call yield method, and your thread one will go to the waiting state. So what happens? Your processor may execute any of the thread among this. So it may execute any thread. It may thread two, thread three, or thread four, or thread five. You don't
Okay.
guarantee it is going to
Which one?
execute,
I see. Yes.
right?
Yeah.
Which
Yes.
one there is no,
I got it.
right?
Yeah.
So for this is the life cycle that we discussed, right? So assume that your thread one, which is in running state. Now, what you want to move this thread one to the waiting state. So what I'll do, I'll call the yield method on that thread, and what happens? That thread goes to the waiting state. So after thread going to the waiting state, what happens? It will be in a waiting state. So you can see there are. So for example, if the thread is running, when you call wait, sleep, or suspend, okay. When you call an yield method, it will go to runnable directly. Okay, I have to check this. So actually, I have seen when you call yield method, your thread will go to the waiting state. But here they have given it a runnable state. Okay, we'll see. But the point is, it is going to, it is not executing. It may be. So generally, it may go to the waiting state, and from waiting state, it will come to runnable. Okay, that's what I have assumed it. But here they have given it from running, it is directly going to runnable. I'll just check and let you know. Right. So you can see on running state, they are calling an yield and they are going to runnable, but I'm not sure whether this is right or wrong. I'll be checking it. But the point is, it is going to the waiting state and it will give chance to the remaining. And similarly, you have a join method. So in the yield method, you don't guarantee which thread to be executed, right? So for example, when I call an yield method on thread 1, any thread among this may execute, and that is not guaranteed that the thread 2 will complete or thread 3 will complete. So intermediate, in some time only, your thread 1 will again start executing before completing your thread 2. Assume that you made yield method on this, and what happens, your thread 1 goes to the waiting state, and assume that your processor has taken thread 2 and it started executing. Assume that before completing your thread 2 only, again my thread 1 game may get a chance. It means before completing your thread 2, your thread 1 is again getting a chance. It means you don't guarantee, or it may get after completing, but you don't guarantee that your get the chance after completing. So there is no guarantee in case of yield method, but that you can achieve in case of joint method. For example, when I am running my main thread, right? So this is my main thread. So when I am running my main thread, what I want, there is some dependency that I have. I want to execute. So I reached some point in my main thread. You can see this diagram, right? So after reaching some point in my main thread, what I want, I just want, I don't want to continue my main thread execution. What I want some thread 1 to complete its execution. After completing my thread 1 of execution only, I want to start again executing main thread. So then on that particular thread, whatever the thread I want to go make to be waiting state, what I will call, I on that particular thread, I will call the join method. So for example, on main thread, what I'm calling thread 1 dot join. It means what happens, your main thread will go to the waiting state. Until what time it will be in the waiting state? Until completing of your join method, sorry, until completing of your thread 1 method. So whenever your thread 1 is completed only, then only your main thread will come out of the waiting state. Assume that your thread 1 completed after 10 minutes, your main thread will come after executing, it will start executing after 10 minutes only. It will wait until completing of your thread 1, because assume that there is a dependency. For example, I want to complete thread 1 and I want to execute main thread. So in that way it will be. For same case, when you call thread 2 dot join, it will start executing thread 2 and your main thread will go to the waiting state. Until what time it will go to the waiting state? Until completing your thread 2. You can read this, and you can also you can read this slide also. That makes more clear. Whatever I told you will be there in the slide. So join method wants the thread to die. It means thread, whatever the thread what we are executing, die means it completed. If it completes execution, it will be dying, right? So you can see in causes the current running thread. So it's not required me to read. You can read and
yeah. Please give me one moment. I'm reading now. Yes, I think this one is straightforward. Yeah, like anyway, yeah, this one is like a main. The sequence is main thread go. It's running and it encounters thread 1 join, and it will wait thread 1 join to complete, then to go to execute the main thread. And
yes.
But in this case, it still goes to but it will encounter thread 2 join again. So it must wait thread 2 join to complete and then go back to the main thread to execute. That's the sequence for this picture, right?
Yes, yes. So once it comes,
yeah, I think I understand this one. Yes, yes. It's like yeah, it meets something. It must like wait this thread to complete, then go back to the main thread.
Yes. So main thread will stop its execution.
Yes.
And wait for.
Yes. And the yield is more like randomly. It's randomly because this one will wait and it will pick. We don't know which thread will go, and then like it's like a randomly to choose, right?
Yes. Yes. So there is a random. Here it is.
Yeah. Sorry. Please give me 3 minutes. I will come back.
Yes. Take your time.
Okay, okay, thank you. Yeah. Yes, I'm back. So yeah.
Okay. So assume that I was considering a simple, like a silly example. Fine. There are three threads, right? Assume that I'm having an interview is one of the thread and result is one of the thread. And if you get selected, assume you are getting selected and the salary is one of the thread, right? So, so can you tell which thread has to call which thread and which one has to wait until the other to complete? So this is
Yeah.
my execution of T1 thread. So this is execution of T2 thread, and this is execution of T3 thread. So can
Yes.
you tell which thread has to call
Yeah.
which one?
T1 call T2 and T2 should call T3.
So I'm telling join. On which thread I need to call the join method.
Oh,
So,
join. Yeah. So
for example, if
I
I
see.
call
I see.
join, your main thread
Mm,
will go to the waiting state, right? Until
yeah.
completing of the
Mm,
similar way here also
yeah.
on which thread has to
Yes.
wait for one to complete.
I see. I see your point. Yeah. Give me one moment. So T1 go T. T2 should be join. T2 join, and T2 and T2 go T3. T3 also join, right?
On T3 what join I need to call? On T2 what join I need to call? You're
On
understanding my point?
what kind of join? You mean?
Whether what kind of join means whether I need to call in T3. So whether
The join on which? Okay, yes. So T2 will call will have call a join or sorry, no. T3 T3 should call a join based on T2.
so it means what is the join here? It should be T2 dot
T
join, right?
Yeah.
So this is my thread. So on T3 thread, what I'm doing, I'm calling T2 dot join. So when you get a salary, so after getting a results of an interview, right, whether you
Mm.
selected or so your T3 is waiting, getting of salary is waiting until completing of what a result
T2,
or
yes. Mm.
interview result, right?
Mm.
Interview result.
And okay, yes. And the T2 should call T1 dot join bracket.
Yes, exactly. So when you
Yes.
get a result after completing your interview only, right? So here it has to call your T1 dot join. So on T3, I'll call what T2 dot join. So it means your T3 will go to the waiting state until completing of your T2, right?
Mm.
Now on when executing T2, when your result will come. So after completing your interview only. So first which will execute? First your interview will execute. After completing your interview, your T2, right? So it is like it will be waiting until that number of time. I think you are clear with this concept, right?
Yes. Mm.
So similarly, you have a sleep method also. So we'll see what is the difference between yield, sleep, and this join method. And you have a join with join is it's a overloaded method. So what is the parameters that it is having? You have a join with 0 parameter, and you have a join with int milliseconds or int. Sorry, it's not int. I think so long milliseconds, and you have a join with long milliseconds and okay, the parameters. Give me a minute. There are three parameters in it. So that is a non-static method. I need to call on. So sorry, it is a long milliseconds, comma into nanoseconds. Okay, this is the three constructors you have. Join with zero parameter, join with a long milliseconds, join with long milliseconds and in nanoseconds. It is like more specifying it. So for example, you generally when you write a join with zero parameter, the corresponding thread is going to waiting state until completing of the thread, right? If it will wait until infinity time. But when you call with long milliseconds, it is going to give the chance to that particular thread, and what happens, it is going to wait only for that particular amount of time. If it completes or don't complete, it does not bother about it. It will start executing the main thread. For example, this nanoseconds also more specific. That's it. Is this clear?
The narrow one. What is narrow seconds?
Nanoseconds is nanoseconds. You are specifying more. Like you have a milliseconds. Nanoseconds is like more specific. I'm giving more amount of.
Oh,
Like,
narrow is more specific than mini because usually we only we use milliseconds. That's it.
yes, yes. Generally, we use milliseconds. So generally, your execution of any program happens in nanoseconds. Actually, even it will not take milliseconds. So you don't see whenever you write it for 100 times. Also, you start running that for loop. You just get in within a nanoseconds of that. Right?
Yes, sorry. Yes, yes. So you mean narrow seconds? Narrow seconds is like more specific than milliseconds, right?
Yes, exactly.
Yeah. And sorry, but so why there are two, like long int, long milliseconds, comma, like int nanosecond. What it means? Both are fine, something like that. For that,
Yes.
for
It is based on your requirement. You can use anything actually. So here, if you see, if I call thread one dot join, what happens? Your main thread will go to the waiting state until completing of thread one. But assume that if I call thread one dot join, and in this join method, if I use some milliseconds of amount of time, like thread one dot join some 1000 milliseconds or some amount of time I'm given. So your main thread is going to waiting state, but but how much time it will go? You just go to the 1000 milliseconds only. After when it comes to your completes your milliseconds, it will start executing your main thread. It will not bother whether thread one completed or not when you
yeah, yeah.
specify the time.
Yeah,
Right?
I understand that point. Like my
But
question is like because I see the third constructor it with like a bracket, long millisecond, comma, then it's like like a int, right? Int, then nanoseconds. So my
yes,
question
yes.
is like it means you can use each of this, right? That's what it means. Or like in when you write the code, you should give two in this bracket. You only give one, right? You can give either milliseconds or nanoseconds, right? That's the point.
Yes, you have two constructors, right? So one is
Yeah.
one parameter, one is two parameter. So when you want to use two parameter, definitely you need to give two things. When you want to one parameter, you can give only nano milliseconds.
Oh, so in that case, you can give two. You let's say I give bracket like 5, comma 4, for example. I can give like
Okay.
this. So that means that means this join will give a chance for the other thread a chance to 5 seconds or 4 nanoseconds. That's that right? That's
Yes,
the meaning.
yes, yes, exactly, exactly.
Either 5 or 4, like something like that, right?
Yes, yes.
Okay, okay. I'm
You can.
because I'm just like I'm like a little bit confused by the third like you know the third like with two parameters because I don't know what it means because with one we are clear it will wait for only give let's say 10 5 oh that's like a 5 milliseconds we know that but then it give us a bracket like a 5 milliseconds comma 4 nanoseconds. So which one I should choose? That's why
That's what.
confused. Yeah.
Ah, it is nanoseconds is lesser than, right? So for example, when you say it is 5 hours 30 minutes. So assume that first it's like 5 hours is the one. So what is the 30 minutes? So 30 minutes is lesser than hours, right? So whatever you said.
Oh, I got a point. I got a point. It means 5. Let's say 5 4. That means it will wait 5 seconds and 4 nanoseconds. That's the point, right? Like
Yes, yes,
5.4, something like that,
yes,
right?
yes, yes.
Oh, now
So
I got it. Now I got it. Okay, okay, okay.
even I'm checking how many
Yeah.
milliseconds equals to nanosecond, and like how many nanoseconds equals to 1 millisecond, right?
Yeah. I got it. Okay. Yeah,
You
because
got it, right?
yes, because I never like see narrow. It's like so specific. Like
Okay. Ah, yes.
yeah.
So generally we will not be using that.
I think I agree with you. Like generally, I think we will not use. Even you, I think generally we don't need to go that deep.
Ah, yes.
Milliseconds is generally I think is enough. It's already very very specific.
Yes, yes. So why they have given nanoseconds? Because the execution, as I told you, it will be very minimal actually. Okay. So for example, here when I execute this thread, so what happens here? I'm just trying to show that join method. So it is not guaranteed that which one is coming, right? It may be main thread, or when I run it in the second time, it may be disorder, right? So
Now you are all at multi-threading, right?
yes, yes. So main started and started like this.
I agree with that. Yes.
So
Yeah.
there is no, we have not. There is this is a
Yes.
normal, right?
Yeah.
So
We talked about it. It's because multi-threading means you don't know which one may come first because they are
yeah.
at like running at the same time.
So here we have two threads, right? So one is your main thread and one more is your child thread.
Child.
So this
Yes.
run which has this is my child thread and this is my main thread. So
Agree. Yeah.
so this thread example is a child thread, right? So
Yes.
for example, when you want this thread example to go to the waiting state, right? So so what I need to do, I need to call the join method on this particular thread, right? So this on the main method, what I'm calling, so this is my main method, right? So this thread example, assume is this is thread one. So what I need to do, I need to call ex dot join. Then what happens? Which one will go to the waiting state? Your, so this there is a chance of interrupted exception, and there is a checked exception, as I told you in the exceptions concept, right? Whenever
Yes.
you have
Yeah.
exception,
Yes.
to handle it, like another I need to write to throws or I need to write try catch. Anything is fine. So here, so if you see here, what happened on my main thread. So this is my, you can see. So on my main thread, what I am calling thread one dot join. So now your main thread will go to wait instead until completion of thread one. The same thing here. So this is my execution of main thread. So on my main thread, what I'm calling ex.join. This ex is what? This is my thread one, right? This is my thread one, right? Ex is my, it's like a thread one means it's like a child thread. So I'm calling the join method on a child thread. So now what should be my output? My output definitely it should be inside M1. After that only your main will execute. So before case, you see there is a interruption, right? But here what happens? Your main will wait. So this thread, your main, this thread is going to be waited. So inside main when it will execute after completing of your inside M1 only, because I am calling ex.join. So if I run it for 10 times also, the output will be inside M1 after main. So there is no interruption. Why? Because your main thread gone to the waiting state. Why it has gone to the waiting state? We called on the current thread. On this current executing my main thread, what I called that particular thread dot join. So that thread one, in the diagram it's a thread one. Here is a thread example. That's your child thread dot join. So until completing of your child thread, this will be in a waiting state.
Yeah,
So
yeah.
you can keep also. So in number of times that you execute, that will be the output. So here,
so here the ex is the
child thread, or
child
you can
ex is
child
the child thread, right?
here ex is a mother thread, right? So like here, like you have a thread one, similarly you have an ex.
Yes, yeah, that's true. Ex is this one, yeah.
So you have here, what do you have here? There are different kinds of methods that you have. So we'll see about weight actually. So as of now, we have discussed about yield, right? So similarly, you have one more method that is nothing but your sleep. So what is the sleep is nothing but, so for example, you want to make some thread to wait for some time, right? In yield case, you are not specifying the time, right? In join case, you are specifying the time, but you are not specifying for that particular thread, right? So so you have a sleep method. So whenever you want to make that particular thread to go for the waiting state some particular amount of time, you can use a sleep method. So if you see the life cycle, so for example, when the thread is running and if I on that particular thread, if I call a sleep method, what happens? It will go to the waiting state. So when it will come out of that waiting state and comes to the runnable state, when the time that you specified in the sleep method was expired. So here what I'm doing, assume that I'm making some before starting this run method, assume that I am making this thread to go for the waiting state. So thread dot, I can have it, this is nothing but a non-static method, sorry, static method I can call with the, so if you see here it is specified with two things, milliseconds and nanoseconds. So I think told you wrong. So milliseconds is greater than nanoseconds when I confused it. So you can place anything. So if I'm using this sleep method, I need to specify that milliseconds. So assume that I'm specifying 1000 milliseconds or 10,000. So 1000. If I specify 10,000, 10 seconds. All right. So you are trying to go make this thread to go to the waiting state for 10 seconds. All right. It means when you are inside M1 will start after completing 10 seconds your M1 will start. So so if it is giving some wait, so generally if you don't have this join method, what happens? Obviously, your processor will execute inside main method, because whenever your current thread is in a waiting state, the child thread is in a waiting state, it obviously gives a chance to the other thread. It will not happen because you have a join method. So your main method will not execute even though whether your child thread is in sleeping mode. So if it sleeps for some amount of time also, it will not be giving a chance. So you see, it is waiting. So there is no
Yeah.
execution. So now your child thread isn't sleeping. Now after that it came out, then only your child thread got started, and again that your main thread got executed.
Yeah, can you please go down to the bottom of the code? I just want to double check. Yeah.
Okay.
Okay. Yes, this part. Yeah. Okay. Yeah. Okay. Thank you. Yeah.
Okay.
Yeah. Yeah. I think yes. I think I understand that. Yes.
Okay. Assume that if you don't have this join, obviously which one will execute? Your main will execute,
Main
because
method.
whenever
Yes.
whenever it went to the waiting state, obviously it will give the processor will give chance to the second thread. So assume that you see main got executed, but still it is waiting because there is a sleep. After that it will start your child. So when you have a join method, your main will not execute. So that's the concept of your join, right? So you uh, so after executing M1 only it will execute, right? And you have something called deadlock. So what is this deadlock? Assume that you have two threads. One is your T1 and T2, right? Assume that you are calling T2.join on current thread T1. What you are doing, you are calling T2.join. What happens? Your T1 will go to the waiting state. Until what time it will go to the waiting state? Completing of your T2. So similarly on T2, what you are trying to do, you are trying to call. So again, what you are doing, you are just trying to call T1.join. So now what happens? Your which one will go to the waiting state? Your T2 will go to the waiting state until completing of your T1. But what happens to T1? So T1 is still in waiting state. So whether T1 will complete? No. Why? Because T1 is waiting for T2. So whether T2 will complete? No, because T2 is waiting for T1. So they both are going to wait for each other for infinity of time, and no thread is going to execute. So there is no code is going to execute. This is called as deadlock. So I think you heard about this term, a deadlock,
Yes.
something
Yes. Yes. I heard of.
happen anything. So that is you call it as deadlock. I think you understood with this join, right? What is deadlock?
Yes. T1 wait for T2 to finish. T2 wait for T1 to finish.
Yes. I'll write a simple deadlock here. So when you run this, you are getting an output, right? So there is no join, there is no sleep. So there is no join. Generally, your main thread will execute, right? So, but what I'm doing on calling of my main thread, so I'm just printing a deadlock, some statement called deadlock. So this will get printed. So after this, there will be no code will execute. So how I'll write a deadlock is simple. So this is my deadlock. Thread dot current thread dot join. So you see this line is a deadlock. No, nothing will execute. You can tell me why it is deadlock. You can tell. So after deadlock, you see no code will execute. So inside main, inside M1. So you wait for, so we start tomorrow the class session also, it will not execute. Nothing will be executed. So why you can see this is deadlock? You can understand why this is deadlock. Thread dot current.
Give me 1 second. Thread, current thread, okay. Current thread join. So, so thread wait for. So this one thread current thread wait for. No, I don't get it.
So here what happened, thread dot current thread dot join your call. So what happens, what is this thread dot current thread? What is my current thread here?
Your current thread here, main string, I don't know this one. Yeah, you put here, like here. It's
So
not. I don't know. It's main or like at this point.
so it's a main thread, right? So what you are executing? You are executing under main thread. So my current thread is main thread.
Oh,
So
okay, main. Okay, yeah.
So if I print this, so before joining, what I'm doing, I'm printing thread dot current thread. So what I'm printing, if I print this, what it is going to print, it will be printing my current thread.
Yes, main thread. Okay.
So what is my current thread? So deadlock, and this is the name of the thread, and this is nothing but the uh, priority of the thread, and this is the group. So what is my current thread here? That is my main thread. So if I run the same statement in my child, what it will be printing? It will be printing thread 0 that I have seen. So this is my child, right? Whatever you are executing inside a run method, what is this? This is my child thread, or the we created this thread. So yesterday I have shown you by running inside this, right? Thread dot current thread. If I write here, so what it is going to print? It is going to print me the child thread.
Yes, yes, yeah.
So
And the thread example is the child class, right?
sorry,
Thread example is the child class.
thread example.
Child
Yes, yes, child thread. Because
and
from
then
main thread we are thread.
yes, yeah. And then
So
we have the run, yeah, from the child level.
there is some confusion that people have. So you understand, first thing, the method is different, the class is different, and the thread is different. So your object is different, right? So for example, there is the thread that is required to execute your thread example. There is a thread that is required to execute your main thread, right? So so internally what I'm telling is nothing but there should be some thread required to execute your thread, this code, right? So what the thread which is executing this code is nothing but your child thread. That is nothing but I'm calling it as a child thread because we have created it inside a main, right?
Yes.
Here you see when I print this child thread, what before what I added here, I added this current thread. So who is executing this thread is nothing but thread 0 is executing, right? So who is executing this main thread? My main. There are two threads, you can say thread 0 and there is a main. So your main is executing the code which is present in the main thread, and there is a thread which is executing the code which is present in the run thread. So you have thread 0 and a thread main, right? Here what I'm doing, you understood, this is nothing but this part is nothing but the current thread. The current thread here is nothing but my main
Yes,
thread is
main thread. Yeah. Okay. Yes.
we are clear with this.
Yes.
So
Yes.
when I call thread dot current thread dot join method, so on what place I'm calling a join method?
From the main method.
On main method I'm calling a join method, right?
Yes.
So before case, if I call here exe dot join method, so here thread example is the child thread, right? I am calling the join method on the child thread. What happens? Your on which thread I am calling? I am calling on the main thread, and what happens? Your child thread will go to the your main thread will go to the waiting state until completing of your thread example child thread, right? So here what I'm calling thread example thread dot current thread dot join. So on which thread I am calling the join method? On current thread. What is the on main thread I am calling the join method? So what thread I am calling the join method? I'm calling the join main thread as a join method. So just like this, you have a main thread. So you have a main thread. So if I call on T1, if I call T2 dot join, what happens? Your T1 will go to the waiting state until completing T2, right? So as that on main thread, I am calling main dot join. This is how I'm doing it, right? So which one will go to the waiting state? Main thread. Until completing of wait what main. So main thread is waiting for a main thread. So it will not come, right? So this is what I'm doing here.
Oh,
so,
okay. You wait for itself. Okay.
Yes. So what is this thread
Main
dot
thread,
thread?
you are waiting for main thread to complete.
Yes.
Okay.
So it will never complete, right? It is waiting for itself. So obviously that is nothing but your dead one.
Okay. 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 Okay.
So it is little bit confusing, but you can understand it. So if I see thread dot current thread, you can divide it. Thread dot current thread. What is this? This is my main thread, right? So
Yeah.
what
Yeah.
I'm doing
Okay.
on which thread I am
Now,
calling thread on main thread only. So thread dot main thread dot join. It means on main thread itself we are calling the on this main thread I am calling the join method. Now what happens? Your main thread will go to the waiting state until completing of my current thread. So what is my current thread here? Main. So main is waiting for main. So nothing will be executed. It will be infinity. Time it is going to be the same. After deadlock and after printing this, you wait for n number of time. In some any amount of time, it will be the same. So you don't see any output, right? So this is nothing but your deadlock. I'm terminating it. Okay. So you just try to make the note of this. I have not shared you.
Okay.
Okay, Mike, I'll be winding up here. Fine.
Yeah.
I think
Okay. Yeah.
right.
Yes. 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 Okay. Yeah. Thank you.
So please go start.
Yeah. Sure. Sure. For this PPT, it's complete. Like, can you send me, or we will wait for some time for this one for the multi-threading?
Okay, I have not sent you multi-threading. I thought I have sent you. No.
No.
Okay,
I
I'll be
don't
sending.
think. Okay.
Tonight by tonight I'll be sending.
Sure. No problem. Yeah.
Okay.
Take your time.
Okay.
Thank you.
Okay. Have a nice day.
You too.
Mike. Bye.
Yeah. Bye.